Biopesticide could defeat insecticide resistance in bedbugs. By Chuck Gill, March 22, 2017. University Park, Pennsylvania. A fungal biopesticide that shows promise for the control of bedbugs is highly effective even against bedbug populations that are insecticide resistant, according to research conducted by scientists at Penn State and North Carolina State Universities. The study suggests that Apprehend, a mycoinsecticide developed by Penn State, likely will provide an important new tool for managing bedbug infestations which have surged in recent years. Bedbugs were all but eradicated from the United States and other industrialized nations after World War II, likely due to the use of DDT and other broad-spectrum insecticides, said study co-author Nina Jenkins, Senior Research Associate in Entomology, College of Agricultural Sciences, Penn State. But in the last few decades, they have reemerged globally as an important public health pest. The researchers noted that pyrethroid insecticides are a mainstay of bedbug control, but there is compelling evidence that many bedbug populations have developed resistance. In addition, this resistance may lead to cross-resistance to other classes of insecticides. In fact, high levels of resistance to 4 neonicotinoids recently were detected in field populations of bedbugs, Jenkins said. Alternative control measures vary in complexity, cost, and efficacy, explained the researchers, who reported their results online in Pesticide Management Science. For instance, the use of high temperatures to kill bedbugs can be effective and has increased in popularity in the last decade. But the cost can be prohibitive, ranging from $500 to $1,000 per room. Other available methods often do not provide satisfactory control. The need for a solution to the resurgence of this pest led Jenkins and colleagues at Penn State to look at entomopathogenic fungi, which have demonstrated effectiveness against other public health pests, such as malaria vectors, cockroaches, and houseflies. Researchers have also shown fungal pathogens to be effective against insecticide-resistant mosquitoes. The result was the development of Apprehend, a patent-pending compound based on Beauveria bassiana, a natural fungus that causes disease in insects. Previous studies have shown that the formulation can be applied as a long-lasting barrier treatment. Bedbugs that cross the barrier acquire fungal spores and go on to spread these among insects that remain in their harborages, resulting in greater than 95% mortality within a week. The goal of this study was to evaluate the efficacy of this product on an insecticide-susceptible lab strain of bedbug and compare that to its effect on 3 field-collected strains known to be resistant to insecticides, Jenkins said. We also compared mortality of these 4 bedbug strains after exposure to either a commercial pyrethroid insecticide or Apprehend. To perform the experiments, researchers applied the fungal-based Apprehend to a quilt fabric commonly used by manufacturers of bedbox springs. They similarly applied a deltamethrin-based commercial insecticide at both high and low concentrations to the same type of fabric. Treated fabric was allowed to dry before bedbugs briefly were exposed to it. The researchers exposed a control group of bedbugs to fabric sprayed with water. The results demonstrated that Apprehend was equally effective against all 4 strains of bedbug, including those with insecticide resistance, achieving mortality rates from 95.5% to 99% within 14 days. The non-resistant bedbugs exposed to fabric treated with chemical insecticide sustained similarly high mortality rates. However, only 16% to 40% mortality was reached among the field-collected resistant strain of bedbugs 14 days after exposure. In 2 of those resistant strains, survivorship after insecticide treatment was not significantly different from the control group, Jenkins said. Perhaps the most important finding of the study, according to the researchers, is that bedbug resistance to pyrethroid insecticides does not confer cross-resistance to infection by B. bassiana. B. bassiana has a unique mode of action with no known resistance or cross-resistance in bedbugs, and it is highly effective on pyrethroid-resistant bedbugs, making it an excellent candidate for use in bedbug management, said Jenkins, who had formed a company, Conadio Tech, to commercialize Apprehend. In addition, the tendency of bedbugs to aggregate is likely to increase the dissemination of the fungus within the harborage and enhance overall population control. Other researchers on the project were Giovanni Bellicanta, postdoctoral scholar in entomology, Penn State, Alexis Barbarin, and Kobe Schall, Department of Entomology and Plant Pathology, and W. M. Keck, Center of Behavior Biology, North Carolina State University, and Jason Osborne, Department of Statistics, North Carolina State University. This work was supported by a grant from the U.S. Department of Agriculture's National Institute of Food and Agriculture, a Research Applications of Innovation grant from the Penn State College of Agricultural Science, and a National Science Foundation Postdoctoral Fellowship in Biology award.